Okay, so welcome to part two of the mathematics grade 10 trigonometry questions. So here we're going to continue with question 4. It's still the same paper that we used in the first video that you were supposed to watch. So here we have question 4. So in question 4 they say, in the diagram below we have A, B, C. So where's A, B, C? There's A, B, C. Then we have A, C, D, and there's A, C, D, right? And we also have A, D, E. Are right angle triangles, and all of them are right angle triangles. And then they also tell us that at BAE, basically this here is all 90 degrees. And then they also tell us that at BAC, which is BAC over here in the first triangle, it is 30 degrees. And then they also tell us that BC is equals to 20 and AD is equals to 60, right? 60 units. So the first question, they basically say calculate the length of AC. Now where is AC first? AC is within the triangle ABC, right? And ACD. But we can't use the triangle ACD because we only know one thing about ACD, and that is AD, which is 60 units. But with the triangle ABC, we do know two things. We know an angle, which is 30 degrees, and we know that one of the sides, which is BC, is 20. And so which trigonometric ratio would work best in this case? Remember, this angle is literally opposite to this side. So if it is opposite to the side, which one would you think we would use? We would use the either tan. You could say tan BC and then get AB and then use Pythagoras to get AC. But the easiest one by far, which because we are looking for just AC, is definitely to say, okay, we have the opposite side to the angle, then we divide it by the hypotenuse, which the hypotenuse in this case is AC. Okay, so this would be sine 30 is equals to 20 divided by AC. And so to get AC onto the other side, we'd multiply by AC on both sides. This side will cancel each other out. We'll be left with 20. And then in this case, then this becomes AC times sine 30, but then we divide sine 30 so that we can get rid of it on this side, and then we have 20 divided by sine 30, and then on your calculator you would find that that is 40 units. Okay, and then they ask us in 4.1.2 the size of CAD. So the size of CAD, now they want the size of CAD. So they want the size of this one here. But remember, we did just find that AC is 40. Now, if you notice in this triangle, which is ACD, that we have two sides and we are looking for an angle, which is ACD. Which trigonometric ratio would work best here? If you notice, is that AD is the hypotenuse. How can I see that? Remember, this right angle triangle has a perpendicular side, and this perpendicular sign here basically points at what the hypotenuse would be, and the hypotenuse is AD. And so since the hypotenuse is AD, right, then we only need what? Another value, and the other value that we do know for a fact is 40. So then this 40 here is which one? It is an adjacent side to the angle. It's next to the angle, and therefore which one has the adjacent side and hypotenuse? It's the adjacent divided by the hypotenuse, that is cos, right? So then we would have cos CAD is equals to AC, or divided by AD, and we know that that is 40 over 60. And then we use the arctan cos of cos to find what the angle would be. So basically you would say on your calculator to find this, you'd say shift and then you'd look for cos, this cos, arc cos, and then after that you put in your values and you would find that it is 48.18 degrees, right? So that's CAD. Right, and then the next question here is 4.1.3, says the length of DE. Now, where is DE? So we have now that this is supposed to be 48.18 degrees, right? As you can see, let me just go and check again. Yeah, 48.18 degrees. And then we are looking for now DE, right? We're looking for this length over there. So how can we get to this length over there? Now, the issue is we only have one thing for the triangle ADE, right? We only know one thing. And what is that? It is only, we only know the information about, AD, which is in the triangle ADE. But now, what do we need to actually find the value of DE? We only need at least one more side or an angle. So in this case, the easiest thing to find is definitely what? The angle. Why? Because BAE is equals to 90 degrees. And notice what is inside BAE. It's actually the 30 degrees and the 48.18, and then it's the unknown, which is DAE, right? Which would help us because this would be opposite to what we are looking for. But then if it's opposite to what we are looking for, and we may be looking for, and we have 60, then we could use one of the trigonometric ratios to find the solution. So in this case, what do we do first? We first have to say 30 plus 48.18 plus this unknown value here, then that is all equals to 90 degrees, and we find that value, and then after that, once we find this value over here, then we can use the trigonometric ratio. So let's see what happens. So basically then we have DAE and BAC plus CAD plus DAE, which is equals to 90 degrees, and it's 30 and 48. And we actually find that in that triangle DAE is basically 11.82 degrees. So this angle in the center here, this one here is 11.82 degrees. But this angle here is opposite to the one that we are looking for. And then the only other piece of information that we have is AD, which is this one over here. So mind you, this is AD and DE are not a hypotenuse, because remember, this 90-degree angle, this 90-degree or perpendicular sign tells us that AE is actually the hypotenuse of this triangle. So which one could we use that does not have the hypotenuse? Between the three trigonometric ratios, it is tan, right, where it would be the opposite side to the angle over the adjacent to the angle, right, or next to the angle. And so that's what we did. And then we would have tan 111.82, that is equals to DE divided by 60. And then we would solve by multiplying 60 onto the other side. So it's 60 tan 11.82 degrees. And that would actually give us 12.55 units. And that would be your final answer for the length of DE, right? And then we have actually to solve for x to correct to one decimal place, where where x is in between 0 and 90 degrees, and that's very important. So if you get any answer that is more than 0 and 90 degrees, then you must have done something wrong. So we have 4.2.1. As you can see, 4.2.1, the only thing you needed to do was being able to take your tan and apply the arctan, so that it's arctan 2.01, and then that would give you 63.54 degrees, right? And then here again, and mind you, when you're solving for x, what you should think about it, how you could think about this, you could think of cos x as just the unknown, or the big X, and then you solve for cos. Once you get to cos, then you just need to use the reciprocal, and you need to you need to use the arc cos, and then you'd have arc cos over 2 over 5, which would give you 66.42, right? And you know how to solve this. You would subtract just as much as you're doing a normal equation, where whatever you do on the left hand side you must do on the right hand side. And then we have a cosec x divided by 2, that's equals to 3. So in this case, the first thing that I did, I multiplied by 2 on both sides. So then this 2 and 2 would cancel each other out, and then we have 3 times 2. But 3 times 2 is just 6. And then cos sec x is related, is the reciprocal of 1 over sine x. So it's 1 over sine x, and so then we would find that of 1 over sine x is equals to 6. And then to swap it around, when we swap it around, sine x becomes a normal sine x without anything underneath it. And then 6 becomes 1 over 6. And then we apply the arc, and it's 1 over 6. And therefore we find that it is 9.59 degrees. So other than that, I really hope that this has been helpful. I will see you next time.